So let's continue to use our neat little shortcut for drawing graphs of quadratic functions. Let's remind ourselves about our original parabola, which is our y equals x squared, and recall that these were the steps that we used as our shortcut, our 1, 3, 5, 7. So let's just get that on there. So notice I've drawn the steps there to show you. So here's our vertex that we start at, and we go over 1, up 1. We go over 1 up 3 steps and over 1 up 5 steps. So notice I've labeled the stairs, the staircase there. So hopefully the step method makes sense to you at this point. So we'll draw the steps on the left as well. And then we have our nice smooth curve that goes through that. So here's our original parabola. And let's remind ourselves that from last day that when here we have the vertex as well. Let's label a few things. Our 0, 0. We have our axis of symmetry is at x equals 0, and there it is in the middle. And also let's remind ourselves in the cloud here then, when a is positive, so a is the number in front of x squared. So a is 1 in this case. When it's positive, we know that the parabola opens upward. So that's a key to remember in the cloud here. Okay, we also looked at, on the next slide, we also looked at negative x squared, and so here's our key steps again, 1, 3, 5, 7, and remember that I said we could use these steps to draw any parabola. So in this case, what's in front of x is a negative, and so instead of going upwards, we want to go over 1, down 1, over 1 down 3, over 1 down 5, and we'll draw the symmetrical points on the left-hand side as well, and there's our parabola that goes through that. So notice that this time we have a frown because the parabola opens down when a is negative. And let's also label our vertex as 0, 0. Our axis of symmetry is still also the same, and there it is right in the middle, a dotted red line. And notice what I did this time. Here's the clue that's going to help us to draw any additional parabolas that are coming up on the next slides. Whatever a is, if I multiply, and this is a times, not an x, if I multiply my steps by a, I can get my new steps. So notice that if I multiplied all these steps 1, 3, 5, 7 by negative 1, I get negative 1, negative 3, negative 5, negative 7. So hang on to that idea, and let's see what we're going to do on the next slide. Okay, what if I had half x squared or 0.5x squared? So I've changed it to a decimal. Half x squared, how could I draw that using the shortcut without having to go through the long process of using a table? Well, what we mentioned on the last slide is whatever a is, if I can multiply my steps by that, I can figure out what the new steps are. So let's take our steps and multiply them. So this is a times, not an x, times 0.5. So what's 1 times 0.5? And 3 times 0.5, so and 5 times 0.5, and 7 times 0.5. If you put those in your calculator, you should get, hey, 1 times a half, so what's half of 1? That's a half. What's half of 3? That's 1.5. What's half of 5? That's 2.5. And half of 7 is 3.5. So here's our new steps. So instead of going over, remember we always go over 1, so we're going to follow this. We're going to go over 1, up a half. So we're going to be in the middle of a square, but that's okay. Then we're going to go over 1 and up 1.5, and then over 1 up 2.5, and over 1 up 3.5. So let's see how that works. We'll start at the origin. So notice we've gone over 1 up a half, okay, and it's hard to be accurate on this grid with these huge dots, but make sure yours is accurate. So we go over 1 up a half. Now we're going to go over 1 and we're going to go over 1 and up 1.5. So I already have my half here, and so another whole square would be right here. Okay, so be careful how you draw that. So now I'm directly at the corner here of this grid. Now we're going to go up 2.5. So we're going to go over 1 and up 2.5. So 2 full squares and another half. So I end up in the middle again. That's okay. And lastly, I want to go up 3.5. So I'm going to go over 1. I'm already in the middle of a square, so I'm going to go, there's my half, and then I need 3 more squares. So 1, 2, and 3 should be right there. And then all you have to do is draw your symmetrical points on the left-hand side. So you could just, you don't even have to count, you could just draw the mirror points on the left. Okay, so that would be there, that would be there, that would be there, and that would go there. And just, you can just check that you're the same distance away from the y-axis. So this point's 2 squares away, so this one's 2 to the left. This one's 3 squares from the center, so this would be 3 squares. And this is 4 squares from the center, and this would be 4 squares from the center. Okay, and let's draw a smooth curve through there, and there we have our parabola. So notice that if you compare 0.5x squared to your original x squared, it looks like it's a little bit wider. So maybe multiplying by a fraction, that means something less than 1, multiplying by a fraction makes your parabola a little bit wider. And so here's, if we had to label what these points were, here's what they would be. So this one is at 1.5. This one is at 2, 2. This point is at 3, 4.5. And this point is at 4, 8. Now notice that these y values are not these. Because remember, these steps are forming a staircase. And they go from one step to the next, whereas these are labeling the coordinate points, and these y values are going right from bottom to top. So it's these y values are saying what the height is right from the bottom, which is the x-axis, right to the top, okay? Whereas when we use these steps, we're just going from this point to this point, for example, and that's why these numbers are not the same as these, so don't get those mixed up. Okay, let's look at one last example. Oh, let's not forget to label our vertex is at 0, 0. Our axis of symmetry is still at x equals 0. There's our dotted line. And here we can compare, here's the original y equals x squared. So I've just drawn it in dotted lines. So just to show you that our y equals 0.5x squared is indeed wider than our y equals x squared original parabola. Okay, so we can say that the parabola gets wider when a is less than 1. And being less than 1 just means a fraction. Okay, a fraction or decimal. So we multiply by a fraction or decimal, we get a wider parabola. Let's see what happens when a is bigger than 1, or a whole number. So a whole number bigger than 1. So we could be multiplying by, if this was 2 or 3 or 4 or anything bigger. Let's take our a and multiply our steps by 2. And so this time, multiplying these steps by 2, we get 2, 6, 10, and 14. So let's use our steps and draw our imaginary staircase to get our new points. So over 1, up 2, and then we're going to go over 1, up 6. So 1, 2, 3, 4, 5, 6 should be there. And then over 1, we're supposed to go up 10. Now we run out of room, so that doesn't matter because we certainly have enough points to be able to sketch our parabola. So always stop whenever you run out of room. You have a good enough idea of where your parabola is at this point. Let's draw our mirror points on the left-hand side, and we just have 2 to draw. One goes there, and one goes there, and we'll draw a nice smooth curve. So notice we don't always have to draw all of our points. Sometimes we have more, sometimes we have less. Okay, let's label our vertex again. That's at 0, 0. Our axis of symmetry is at x equals 0, our dotted line. And let's compare to the original y equals x squared. So here's my dotted original y equals x squared. Notice what happened this time. Instead of getting wider when we had a decimal here, notice it's gotten narrower. So here it's gotten taller and narrower than our original. Okay? So we could say that the parabola gets narrower when a is bigger than 1. And so hopefully that will help you to draw any parabola without having to go through the long process of using a table of values.